Okay, hi everybody. Today we're going to be going through 11.3 geometric sequences. And as a warm-up, I have you taking a look at some sequences here. And if you notice, they're not arithmetic. So we're not adding a number, the same number, or subtracting the same number each time to get to the next term. What we're doing here is we're multiplying by a number. And the easiest way you could figure out is what number we're multiplying by is to look at the ratio between consecutive terms. So 2 divided by 1, right? So the second term divided by the first term gives us 2. And it looks like we're multiplying by 2 to get to the next term. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So 8 times 2 would give me 16. If we look at the next ratio, we get 168 divided by 336. If you're not sure, you can use your calculator. But it looks like we're multiplying by a half. To get to each new term, I multiply by a half. So 42 multiplied by a half, the next term would be 21. 1 divided by 0.1 or 10 divided by 1 or 100 divided by 10 gives me 10. So the ratio, again, you can do this in your calculator if you want, right? 1 divided by 0.1 is just 10. So my common ratio here is 10. 100 times 10 gives me my next term of 1,000. 300 divided by 900, that's a third. So it looks like I'm multiplying by a third to get to each of the next terms. So in this case, I would have 100 times a third, or 100 over 3. That would be my next term. So just a little way of, introducing geometric sequences. We're going to break it down in our lesson today. At the top here, I'm just going to put an example, a nice easy example where we start with 2 and we multiply by 2 each time to get to the next term. Just put a couple of numbers here just so we have something to reference as I explain these. The definition of a geometric sequence is that the ratio between consecutive terms is constant. The ratio between consecutive terms Okay, so what do I mean by consecutive terms? One right after the next. So we've got 4 divided by 2. We've got 8 divided by 4. We've got 16 divided by 8. We have 32 divided by 16. If you notice, all of those ratios are equal to 2. So that makes this a geometric sequence. The ratio between consecutive terms is constant. It's always going to be 2. Between consecutive terms is called the common ratio. And it's denoted by the letter R. The geometric mean, so in other words, if we had our sequence example above, but I didn't know that middle term there, I would take the square root of the product of those two numbers. So let's write that down first. The square root of the product of two numbers. So in this case, it would be the square root of 2 times 8, which is the square root of 16, which is 4. Right. I don't know if you can hear it in the background, but there is a woodpecker outside the house right now. So I'm sorry about that. There's a little bit of you'll hear a tapping. There it is. All right, so the geometric mean is the square root of the product of those two numbers, and we'll do some more practice on that on the last page. So it says, for the following examples, determine whether or not they're geometric. So we just want to look at the ratio between all the terms that we have and see if we get the same value. So we've got 15 divided by 5. We've got 45 divided by 15. We've got 135 divided by 45. All right, so all of those ratios equal 3. 15 divided by 5 is 3. 45 divided by 15 is 3. And so forth. So yes, this is geometric. And our common ratio is equal to 3. Let's take a look at the next one. So we've got 30 divided by 15, that's 2. We've got 45 divided by 30. Oh, that's not 2. So we know this is not geometric. All right, now we could take it up a notch a little bit. Are the following sequences arithmetic, geometric, or neither? So if you recall from our lesson on arithmetic sequences, we want to see if there's a common difference between terms. So I'm going to look at the common difference first. So negative 24 minus 6, that would give me minus 30. So am I subtracting 30 to get to the next term? I am not. All right, so I know that it is not arithmetic. All right, now let me look at the common ratio. The common ratio would be negative 24 divided by 6. That gives me negative 4, right? Well, am I multiplying by negative 4 to get to the next term? Yes, I am. Negative 4 times negative 24 is 96. So this is geometric. And the ratio is equal to negative 4. All right, let's do it again for number 4. First, we want to see if there's a common difference. 20 minus 8, that gives me 12. Am I adding 12 to get to the next term? Yes, 20 plus 12 is 32. 32 plus 12 is 44. So right out of the gate, we know we have an arithmetic sequence. That saves us a little trouble. We like that. And in this case, our common difference is 12. So for number 3, we had a geometric with a common ratio of negative 4. And for number 4, we have an arithmetic sequence with a common difference of 12. All right, we're going to write some formulas down. If you recall, I made a point in the last lesson about recursive formulas mean that you're going to need to know the previous term if you're going to use a recursive formula versus an explicit formula where the previous term is unknown. All right, let's write these down. So we've got a sub n equals a sub n minus 1 times r. A sub n minus 1, that always throws everybody off, right? That means the term before a sub n. And r, of course, is our common ratio. The explicit formula, a sub n equals a sub 1 times r to the n minus 1. Now, n is the value, what value are we at in the sequence? So I'm going to just write here the term number, we'll say, in the sequence. And you're probably thinking, I don't know what you mean, so don't worry. I'm going to give you an example. The term number in the sequence, r is the common ratio. And a sub 1 is the value of the first term. So students always get really confused in this unit with the notations. Let me give you an example here. We'll stick with our easy example where we do 2 and we multiply by 2 to get to the next term. So our common ratio is 2. notation for the value of the first term is a sub 1, the value of the second term a sub 2, and so forth. N in this case is 1, 2, 3, 4, and 5, right? So that is what we mean by N. What number term are we in the sequence? So for 5 and 6, it says find the 19th term in each sequence. And be careful because they are not telling you whether or not we have geometric or arithmetic. So we need to figure that out. So we'll look at the common difference first and we'll see, do we have that? So if we do 33 minus 11, we're going to get 22. Are we adding 22 to get to the next term? So no, we are not. So it's not arithmetic. That helps us a little bit. So it must be geometric, but let's just confirm it. So we want to look at the ratio this time. I'm going to do 33 divided by 11 gives me 3. Are we multiplying by 3 to get to the next term and the next term? Yes, we are. All right, so this is a geometric sequence. And because we need the 19th term, we have to use the explicit formula because we don't know the term before. We don't know the 18th term, so we can't use the recursive formula. We're going to use explicit. Now, don't forget, you should have your formula sheet handy. And we're going to just go to our geometric sequence formulas, and you can look at it. It's right here. Right, I've been giving you a lot of formulas. That's why I recommend highly that you've printed this out and you can use it as a reference sheet throughout the unit. So we're going to write that formula out. So we know that it is a sub n equals a sub 1 times r to the n minus 1. N in this case is 19. We want the value of the 19th term, and that's going to be equal to the value of the first term, which is, of course, 11. We've identified our common ratio as 3. And when we simplify that, we get the value of the 19th term is equal to 4, 261, 625, 379. Kind of a big number there. All right, let's look at the next one. We have to identify arithmetic or geometric first. So let's see, 17 minus 20, we get negative 3. So are we subtracting 3 to get to the next term? It looks like yes. 17 minus 3 is 14, 14 minus 3 is 11, and so forth. So we know we have an arithmetic sequence. So you go to your formula sheet. We're going to go to the top of the formula sheet for arithmetic formulas, and we're going to use the explicit formula, right? This guy right here. We're going to write that formula down. Always helpful just to rewrite the formula so we don't make any mistakes. The value of the nth term equals the value of the first term times n minus 1 times d. So in this case, the value of the 19th term is equal to the value of the first term, 20, plus 19 minus 1 times our common difference, which we found. D, that's kind of sloppy. D is equal to 3, negative 3. And when we use our calculator to solve that out, we're going to get negative 34. All right, last page here. We've got, we're going to look at some graphs. So we're going to do arithmetic, and we're going to do geometric. We're going to make this real easy. We're going to do a table of values. We'll do 4 terms for each. All right, starting both of them with 2, I'm going to make my common difference in my arithmetic example 2. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. For my geometric sequence, I'll start at 2 and I'll make my common ratio 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And then I'm going to draw a graph for both of those. We'll keep it simple. All right. And we'll do our y-axes by 2s. Same over here. Need a little bit more space for this guy because we have to go all the way up to 16. And then we're going to go ahead and plot these. So we've got 1 and 2, 2 and 4, 3 and 6, 4 and 8. And you'll notice with this one, we've got a line. We've got a linear graph. Now, if we plot our other graph, our geometric graph, we've got 1 and 2, 2 and 4, 3 and 8. Whoa, all of a sudden you jump up a lot, right? 4 to 16. And so I don't know if you notice what this shape is. Okay, but this is an exponential graph. So all graphs of arithmetic sequences are linear. All graphs of geometric sequences are exponential. All right, we have our last bit here where we talked about the geometric mean being the product of two numbers, the square root of the product of two numbers. All right. So to find that middle term, we're going to do the square root of 20 times 80. And we're going to get, in that case, the square root of 20 times 80 gives us 160, and the square root of 160 is 40. We've got the square root of 3 times 18.75, and that'll give us 7.5. And the last one is the square root of 28 times 5103, which gives us 378. All right, that's the end of this lesson on geometric sequences. Thank you for watching.